Hello there, and welcome to this quiet corner of the cosmos, where wonder meets the whisper of starlight. Tonight, we're not just looking up at the sky, we're asking whether something might be looking back. On July 1st, 2025, astronomers discovered an object so massive, so ancient, and so peculiar that it challenges everything we thought we knew about visitors from beyond our solar system. This is 3I Atlas, an interstellar wanderer larger than Manhattan, older than Earth itself, and behaving in ways that make even seasoned scientists pause and wonder. Could this 7 billion-year-old traveller be more than just a comet? Could it be watching us? I'm glad you found your way here tonight, wherever you are in the world. Whether you're settling into bed with questions that won't quiet, or simply letting your mind drift toward mysteries larger than our daily concerns, this is a place where curiosity can unfold slowly, without pressure, without rush. We're going to take a gentle journey through one of the most intriguing discoveries of our time, exploring not just what we've found, but what it might mean for our place in this vast, patient universe. If this kind of cosmic contemplation resonates with you, you might consider subscribing. It helps this quiet signal reach other curious minds who, like you, find comfort in the bigger questions. No pressure, of course, just an invitation, like the faint light of a distant star that may or may not be trying to tell us something. So settle in, let your thoughts slow to the rhythm of galactic rotation, and prepare to encounter a mystery that arrived from the deep darkness between stars, carrying with it secrets that predate our entire world. In the pre-dawn hours of July 1st, 2025, while most of Earth slept, a telescope perched high in the Chilean desert detected something extraordinary. The Atlas survey system, designed to watch for dangerous asteroids, had found something that didn't belong to our solar system at all. At first, it appeared as nothing more than a moving dot of light, but within days, astronomers realized they were witnessing the arrival of a visitor from another star system, the third confirmed interstellar object ever discovered. They named it 3I Atlas, where the I stands for interstellar and the 3 marks it as the third of its kind. But numbers and designations can't capture what makes this object so deeply unsettling to those who study it. This isn't just another space rock tumbling through the void. This is something that formed when the universe was young, when the Milky Way itself was still learning how to arrange its spiral arms, when Earth was nothing more than cosmic dust waiting to coalesce. The age alone is staggering. Computer models suggest 3I Atlas is more than 7 billion years old, making it not just the oldest comet ever identified, but older than our entire solar system by billions of years. To put this in perspective, when 3I Atlas first formed in some distant stellar nursery, our sun didn't exist. Earth didn't exist. The very materials that would one day become our planet were still scattered across space, waiting for gravity's patient hand to gather them together. This ancient wanderer originated from what astronomers call the Milky Way's thick disk, a region populated by older stars with different chemical signatures than our own sun. For eons beyond counting, 3I Atlas has been drifting through the cosmic dark, following a tilted orbit around our galaxy's center, carrying within its frozen depths the chemical memory of a universe far younger and stranger than the one we know. But age, while remarkable, isn't what makes 3I Atlas truly extraordinary. It's the sheer impossibility of its size and the mystery of its behavior that has astronomers quietly questioning their assumptions about how the universe works. When you look up at the night sky, the stars appear as pinpricks of light, distant and serene. It's easy to forget that space is mostly empty. Unimaginably vast stretches of nothing punctuated by occasional islands of matter. The odds of any object surviving a journey between star systems are vanishingly small. The odds of something massive surviving such a journey are even smaller. And yet, here is 3I Atlas, defying probability with its very existence. The object is enormous, larger than Manhattan, with a nucleus measuring less than 1.86 miles across, but surrounded by a glowing coma that stretches across 26,400 kilometers. To put this in perspective, that's nearly twice the diameter of Earth. But even more astonishing is the extended carbon dioxide atmosphere detected by NASA's SPHEREx mission, which spans at least 348,000 kilometers in radius. That's almost the distance from Earth to the Moon. This scale challenges everything we thought we knew about interstellar objects. 3I Atlas is roughly 1 million times larger than 2I Borisov, the previous interstellar visitor. According to the statistical models that govern celestial mechanics, we should have discovered numerous smaller objects before ever encountering something of this magnitude. It's like finding a blue whale before discovering plankton. Possible perhaps, but so unlikely that it suggests we're missing something fundamental about how these objects form, survive, or arrive. The size isn't just remarkable, it's practically impossible. How does something this massive survive the harsh journey between stars? How does it maintain its structure across billions of years of exposure to cosmic radiation, gravitational perturbations, and the slow erosion of deep space? Most smaller objects would be torn apart or worn away to nothing. Yet here is 3I Atlas, not only intact, but actively outgassing as it approaches our Sun, as vigorous and mysterious as if it had just formed yesterday. The object's trajectory adds another layer to the puzzle. 3I Atlas approaches from the direction of Sagittarius, which points toward the central region of our galaxy. Its hyperbolic orbit, with a record-breaking eccentricity of 6.1, marks it definitively as an interstellar visitor. But this isn't a random flyby. The object's path will take it unusually close to Venus, Mars, and Jupiter this fall, an alignment that statisticians calculate as having only a 0.05% probability if the arrival time were truly random. This raises an uncomfortable question that whispers at the edges of scientific discourse. Could this trajectory be intentional? Science often advances not through grand revelations but through quiet anomalies, small details that don't fit, observations that resist explanation. With 3I Atlas, these anomalies are accumulating like storm clouds on a distant horizon. The James Webb Space Telescope, humanity's most powerful eye on the cosmos, turned its gaze toward the interstellar visitor and found something unexpected. The object's atmosphere is unusually rich in carbon dioxide, making it chemically distinct from 2I Borisov, which contained far more carbon monoxide. This might seem like a minor difference, just one atom's variation in a simple molecule. But in the precise language of astronomy, such differences speak volumes about origin, composition, and history. More intriguing still are the spectroscopic observations from the Very Large Telescope in Chile. When astronomers analysed the light streaming from 3I Atlas's coma, they found cyanide and nickel in the outgassing plume. The presence of cyanide isn't particularly unusual. It's found in many comets. But the nickel discovery came with a twist that has raised eyebrows throughout the astronomical community. There was no iron. This absence is deeply strange. Iron and nickel are typically forged together in the nuclear furnaces of dying stars. They're atoms born in the same stellar explosions that seed the galaxy with heavy elements. They're found together in meteorites, in planetary cores, in the cosmic dust that forms new worlds. Their separation is virtually unheard of in natural astronomical objects. Harvard physicist Avi Loeb, known for his willingness to consider unconventional possibilities, pointed out that pure nickel without iron resembles the signature of industrial alloy production, a process unknown in natural astrophysical environments. This observation, while speculative, adds to the growing collection of details that don't quite fit the standard model of what a comet should be. The object's activity pattern deepens the mystery. 3I Atlas was already bright and glowing when first detected in May 2025, when it was roughly 6.4 astronomical units from the Sun. Too distant for water ice, to sublimate under normal circumstances. NASA's TESS mission observed this persistent glow as early as May, suggesting that whatever drives the object's activity operates by different rules than those governing typical comets. Yet perhaps the most unsettling observation of all is what astronomers have dubbed the anti-tail phenomenon, a discovery so contrary to our understanding of cometary physics that it borders on the impossible. In the gentle dance of celestial mechanics, certain rules seem inviolable. Comets develop tails that stream away from the sun, pushed outward by solar wind and radiation pressure. It's as predictable as water flowing downhill, as reliable as the phases of the moon. This fundamental behavior is so well understood that it forms the basis of how we identify and classify these icy wanderers from the outer reaches of our solar system. 3i Atlas breaks this rule. Using images from NASA's SphereX mission, astronomers detected something that shouldn't exist: a faint, teardrop-shaped tail stretching behind the object, aligned directly toward the sun rather than away from it. This anti-tail phenomenon completely defies our understanding of how cosmic objects behave in the solar wind flowing uphill, as if gravitated. It's as if water were pushing instead of pulling. Avi Loeb, writing in a blog post that sent ripples through the astronomical community, described his disbelief at the observation. If 3i Atlas is truly a comet, he noted, then dust particles should be pushed by sunlight away from the sun, not toward it. The presence of material flowing sunward suggests either an unknown physical process or a fundamentally different type of object operating under principles we don't yet understand. This anti-tail isn't just puzzling, it's paradigm challenging. It suggests that 3i Atlas might not be subject to the same physical laws that govern other objects in our solar system, or perhaps that it possesses some form of internal radiation pressure. Neither explanation fits how the universe works. The implications stretch activity that generates forces stronger than solar fortibly within our current understanding of how beyond mere scientific curiosity. Throughout history, anomalies like this have often preceded major shifts in our understanding of reality. When Galileo first pointed his telescope at Jupiter and saw moons orbiting another world, it shattered the Earth-centered model of the universe. When Edwin Hubble observed that distant galaxies were rushing away from us, it revealed that the universe itself was expanding. Could the anti-tail of 3i Atlas be pointing toward another such revelation? As we watch this ancient visitor approach its closest point to our sun, scheduled for late October 2025, more questions emerge. The object will pass behind the sun as viewed from Earth, hidden from our most powerful telescopes at the moment of its closest approach. Some researchers find this timing suspiciously convenient, as if the object were deliberately avoiding detailed observation at its most active phase. But perhaps most intriguingly, 3i Atlas's trajectory seems almost designed to provide optimal viewing angles of multiple planets in our solar system. It will pass remarkably close to Mars in early October, offering what some describe as a perfect reconnaissance opportunity. The European Space Agency has already announced plans to observe the object with their Mars orbiters during this close encounter, hoping to gather data that might finally explain what we're really looking at. As we continue to monitor this mysterious visitor, each observation seems to deepen rather than resolve the puzzle. The ancient wanderer from the galactic disk carries secrets that may reshape our understanding of what's possible in the cosmos. And some researchers are beginning to wonder whether those secrets might be more profound and more intentional than anyone initially dared to imagine. The question that haunts the edges of scientific discourse grows stronger with each passing observation. Could 3i Atlas represent something more than a natural phenomenon? Could this 7-billion-year-old traveller be carrying a message or conducting a mission that we're only beginning to glimpse? As October approaches and the object draws closer to its mysterious rendezvous with our inner solar system, we'll continue to watch, to measure, and to wonder. Because sometimes the most important discoveries aren't the ones we expect to find, but the ones that find us. Next time, we'll explore the even more unsettling possibility that 3I Atlas might represent evidence of the dark forest hypothesis, the idea that the universe is full of silent civilizations, each hiding from the others, and that our cosmic visitor might be conducting the kind of reconnaissance mission that could change everything we thought we knew about our place in the galaxy. Until then, rest well, and remember that even as you sleep, ancient travelers continue their patient journeys through the dark between the stars. There's something deeply unsettling about being watched without knowing it. That prickle of awareness, the sense of eyes upon you when you thought you were alone. Now imagine that feeling scaled up to encompass not just yourself, but your entire species, your whole world, perhaps even your corner of the galaxy. This is the quiet dread that some scientists are beginning to confront as they study 3I Atlas and its peculiar behaviour. The idea didn't emerge from science fiction or conspiracy theories. It arose from careful analysis of the object's trajectory, timing, and unprecedented characteristics. When Harvard physicist Avi Loeb and his colleagues ran the numbers, they discovered something that made them pause. The probability of 3I Atlas's arrival, time and planetary alignment being purely coincidental was vanishingly small. Just 0.05% if the timing were truly random. This calculation points toward a possibility that challenges our most 3I Atlas isn't just basic assumptions about our place in the universe. What if an ancient comet following the laws of celestial mechanics? What if it's something far more purposeful? A reconnaissance mission from a civilization so old and advanced that their technology appears to us as natural phenomena? The evidence, while circumstantial, is mounting. The object's size defies statistical probability. Its chemical composition includes signatures unknown in natural astrophysical environments. Its anti-tail behavior violates our understanding of cometary physics, and its trajectory provides optimal viewing angles of multiple planets in our solar system, as if designed for comprehensive surveillance. Consider the timing of its closest approach to the Sun, scheduled for late October 2025. From Earth's perspective, 3I Atlas will be hidden behind our star at the moment of its peak activity, a cosmic eclipse that prevents our most powerful telescopes from observing it during what should be its most revealing phase. Is this merely unfortunate timing, or could it represent something more deliberate? The object's approach from the direction of Sagittarius adds another layer to the mystery. This region points toward the galactic center, the ancient heart of our Milky Way, where the oldest stars reside. If an advanced civilization wanted to establish a network of observation posts throughout the galaxy, the central regions would provide ideal staging grounds, stable, resource-rich environments with gravitational advantages for launching long-term missions. But perhaps the most chilling aspect of the 3I Atlas puzzle isn't what it might be, but what it might represent. If this object is indeed a form of technology, it could be evidence of something that cosmologists call the dark forest hypothesis, one of the most sobering attempts to answer why, in a universe teeming with potentially habitable worlds, we seem to be so utterly alone. The universe should be noisy, with hundreds of billions of stars in our galaxy alone, and potentially trillions of galaxies beyond. The cosmos should be buzzing with radio signals, alive with the chatter of countless civilizations. The sheer scale of space and time suggests that intelligent life should be common, perhaps even inevitable. And yet, when we listen to the cosmos, we hear only silence. This paradox has a name, the Fermi paradox, after physicist Enrico Fermi, who famously asked, "Where is everybody?" It's a question that has haunted scientists for decades, spawning countless theories and explanations. Perhaps life is rarer than we think. Perhaps intelligence is a cosmic accident. Perhaps civilizations tend to destroy themselves before they can reach out to the stars. But there's another possibility, one that sends a chill through those who contemplate it seriously. Perhaps the galaxy is full of civilizations, but they're all hiding. Perhaps the universe is like a dark forest, where every intelligence moves carefully through the shadows, afraid to make a sound, afraid to light a fire, afraid to reveal their location to the hunters that might be lurking in the cosmic night. The dark forest hypothesis suggests that any spacefaring civilization would view other intelligent life as an inevitable threat. In a universe where resources are finite and distances are vast, the safest strategy might be to eliminate potential competitors before they become dangerous. This creates a cosmos where revealing your presence is an act of ultimate peril, where any signal sent into space becomes a beacon for hostile attention. The mathematics of this scenario are grimly elegant. If even a small percentage of civilizations are aggressive, and if the penalty for being discovered is extinction, then silence becomes the only rational survival strategy. Every civilization becomes a hunter, moving carefully through the dark forest of space, ready to destroy this framework, humanity, any other life they encounter. In has made a terrible mistake. We have not been silent. For over a century, our radio and television signals have been leaking into space, creating an expanding bubble of electromagnetic noise that announces our presence to anyone with the technology to detect it. We've lit a torch in the dark forest, and now we're waiting to see what emerges from the shadows. If 3i Atlas represents surveillance technology from such a hidden civilization, it would suggest that our cosmic torch has indeed attracted attention. The object's behavior, its optimal viewing angles, its unusual activity patterns, its convenient timing, could be the hallmarks of a reconnaissance mission designed to assess whether humanity represents a threat or an opportunity. This interpretation casts the object's ancient age in a new light. A civilization advanced enough to conduct interstellar surveillance missions might also be old enough to have witnessed the rise and fall of countless other species. They might have learned through experience that young civilizations like ours are dangerous variables in the galactic equation, unpredictable, rapidly expanding, potentially threatening to the delicate balance that older civilizations have worked millennia to maintain. There's a peculiar intimacy to being observed without your knowledge. Every move you make, every signal you send, becomes data in someone else's analysis. If 3i Atlas is indeed a form of surveillance technology, then humanity is currently the subject of the most comprehensive study we've never agreed to participate in. Consider what such observers might be cataloguing about us. Our electromagnetic signatures tell the story of our technological development, the progression from simple radio broadcasts to complex digital communications. Our atmospheric composition reveals the impact of our industrial civilization. Our orbital mechanics, visible through our satellites and space missions, demonstrate our expanding reach beyond our home world. But perhaps more importantly, they might be studying our behavior patterns. How do we respond to challenges? How quickly do we adapt to new technologies? How do we treat other species on our planet? Are we the kind of civilization that might pose a threat to galactic stability? Or are we potential partners of 3i Atlas's arrival in some larger cosmic community? The timing may not be coincidental. In recent decades, humanity has reached several technological milestones that might trigger interest from advanced observers. We've developed nuclear weapons capable of destroying our own civilization. We've begun to seriously explore space, with missions to Mars and ambitious and study exoplanets, demonstrate plans for lunar colonies. We've started to detectrating our growing awareness of the broader universe, most for extraterrestrial intelligence ourselves. Significantly, we've begun to search SETI programs, scan the skies for signals from other civilizations, while our radio telescopes probe deep space for signs of technological activity. From the perspective of a hidden galactic community, this might represent a crucial transition, the moment when a young species begins to actively look for others. Such a moment might trigger protocols established eons ago, by civilizations that have learned through hard experience how to manage the emergence of new intelligences. 3i Atlas could be part of a systematic assessment process designed to determine whether humanity is ready for contact or whether we represent a threat that needs to be contained. The object's close approach to Mars in early October takes on new significance in this context. Mars represents humanity's next major expansion target, the world where we plan to establish our first self-sustaining colony beyond Earth. If 3i Atlas is conducting surveillance, it would make perfect sense to closely examine the planet that might become humanity's second home. The European Space Agency's plans to observe the object during its Mars flyby suddenly seem less like scientific opportunity and more like a moment of mutual observation, humanity studying the watcher while being studied in return. It's a cosmic version of that moment when you realize someone has been watching you and you both freeze, caught in the act of observation. Intelligence leaves fingerprints, not always obvious ones, but patterns that speak to purpose, design, intention. When we look at a honeycomb, we see the mathematical precision of hexagonal cells and recognize the work of minds, even if those minds are very different from our own. When archaeologists uncover ancient tools, they can distinguish between rocks shaped by chance and stones crafted with purpose. The challenge with 3i Atlas is that we're looking for signs of intelligence on a scale and time frame that stretches our ability to recognize patterns. If this object represents technology from a civilization billions of years older than ours, their methods might be so advanced, so subtle, that they appear natural to our current level of understanding. Yet certain details continue to accumulate that suggest intentionality. The object's trajectory, for instance, follows what mission planners would call an optimal reconnaissance path. It approaches from the direction of the galactic center, where older civilizations might naturally establish themselves. It passes close to multiple planets in our system, providing comprehensive observational opportunities. It times its closest solar approach to coincide with minimal visibility from Earth, avoiding detailed observation during its most active phase. Even the object's composition tells a story that presence of pure nickel, without iron, might be more complex than simple chemistry. Theia signature that resembles industrial alloy production rather than natural stellar nucleosynthesis could be evidence of artificial construction. The unusual carbon dioxide atmosphere might serve purposes beyond simple sublimation, perhaps providing a medium for sensor arrays or communication systems. The anti-tail phenomenon remains the most compelling evidence of non-natural behavior. For an object to direct material toward the sun rather than away from it requires either unknown physics or active propulsion. If 3i Atlas possesses some form of thrust capability, even minimal station-keeping motors, it would explain both the anti-tail and the precise trajectory that has brought it so conveniently close to our planetary system. But perhaps the most telling sign of potential intelligence is what the object doesn't do. Despite its massive size and unusual properties, 3i Atlas makes no attempt to communicate with us directly. It sends no radio signals, displays no obvious artificial structures, makes no gestures of contact. This silence might be the strongest evidence of all that we're dealing with advanced intelligence. A civilization sophisticated enough to conduct covert interstellar surveillance would understand the psychological and sociological impact of first contact. They would know that revealing themselves prematurely could destabilize the very civilization they're studying. The absence of communication might itself be a form of communication, a message that we're being observed but not yet deemed ready for direct interaction. They date our entire world something profoundly humbling about the possibility that we're being watched by minds that pred. If 3i Atlas represents technology from a 7 billion year old civilization, then we're in the presence of intelligence that has been contemplating the cosmos since before our sun began to shine. Such ancient observers would have witnessed the birth and death of countless stars, the formation eons understanding Kerr of planetary systems, the rise and fall of civilizations we can barely imagine. They would have seen patterns in galactic evolution that span ents in space and time, that remain invisible to our young, appear as a brief flicker of activity on eyes. From their perspective, humanity might a small world orbiting an unremarkable star. Our entire recorded history, from the first cave paintings to the latest space missions, would represent less than 0.001% of their existence. We are, in cosmic terms, barely out of the cradle, just beginning to take our first tentative steps into the larger universe. Yet despite this vast disparity in age and experience, they would have reason to watch us carefully. Young civilizations are unpredictable variables in the galactic equation. We possess the dangerous combination of advanced technology and primitive wisdom, the ability to split atoms before we've learned to live peacefully with our neighbours. We represent both tremendous potential and significant risk. The Watchers, if they exist, would have learned patience on a scale we can barely comprehend. They would understand that civilizations develop at their own pace, that interference often does more harm than good, that wisdom cannot be rushed. Their observation of us might be part of a process that has been repeated countless times across the galaxy, the careful monitoring of emerging intelligences to determine their ultimate trajectory. This puts humanity in the peculiar position of being unknowing participants in an examination we didn't know we were taking. Every choice we make, every technological advance, every decision about how to treat our planets and each other becomes part of a vast assessment whose criteria we can only guess at. The implications are both inspiring and terrifying. If we're being watched by benevolent observers, then perhaps we're not as alone as we sometimes feel. Perhaps there's a community of minds out there waiting for us to mature enough to join them. But if the Watchers have darker intentions, if they're assessing us as a potential threat to be eliminated, then our very existence might hang in the balance of decisions we're not even aware we're making. As I speak these words into the quiet night, 3i Atlas continues its ancient journey toward the inner solar system. Each day brings it closer to its October rendezvous with our sun, and with it, the possibility of answers to questions we've barely learned how to ask. The European Space Agency's Mars orbiters stand ready to observe the object during its close approach to the red planet. These instruments, originally designed to study Martian geology and atmosphere, will instead turn their sensors toward an interstellar visitor that might be studying us in return. It's a moment of profound symmetry. Humanity's robotic ambassador, something that might itself be a robotic ambassador, Fromidors preparing to examine a civilization unimaginably older than our own. The data collected during these observations could fundamentally change our understanding of what's possible in the universe. If 3i Atlas proves to be a natural object, albeit an extraordinarily rare and ancient one, it will still represent a treasure trove of information about the early galaxy and the processes that shape interstellar wanderers. But if the accumulating evidence of artificial characteristics proves correct, we may be witnessing the first confirmed detection of extraterrestrial technology. Either outcome would be profound. Either answer would change how we see ourselves and our place in the cosmos. The confirmation of advanced alien surveillance would shatter our assumptions about cosmic loneliness and force us to reconsider every aspect of our relationship with the universe. But even the discovery of a purely natural object of such age and scale would expand our understanding of what's possible in the cosmic arena. As October approaches, astronomers around the world are preparing their instruments, crafting observation schedules, and formulating theories about what they might discover. The international scientific community has rarely been so focused on a single object, so united in their curiosity about a visitor from the deep dark between the stars. Yet there's an undercurrent of tension in these preparations, a recognition that we might be on the verge of a discovery that changes everything. If 3i Atlas is what some researchers suspect it might be, then the October observations could mark the moment when humanity first confirmed that we are not alone, that we have never been alone, that ancient eyes have been watching our species stumble toward technological maturity. The object's timing feels almost theatrical. Its arrival in 2025, during an era when humanity is finally developing the tools to study such visitors in detail, when our own space technology is advanced enough to appreciate the engineering challenges of interstellar travel, when our understanding of galactic evolution has reached the point where we can contemplate the possibility of ancient civilizations. It's as if 3i Atlas has been waiting for us to become sophisticated enough to recognize what we're looking at. As if this 7-billion-year-old wanderer has chosen this moment, this generation, to reveal itself to a species that has finally developed eyes capable of seeing beyond its own solar system. The implications of this timing are staggering. If the object's arrival is intentional, if it represents contact from an intelligence that has been monitoring our development, then we may be witnessing the most significant moment in human history, the transition from cosmic isolation to galactic citizenship. But even if 3i Atlas proves to be entirely natural, its discovery reminds us that the universe is far stranger and more wonderful than we've imagined. It tells us that ancient objects from the dawn of the galaxy still wander through space, carrying within their frozen cores the chemical memories of stellar nurseries that existed when the universe was young and strange and full of possibilities we're only beginning to glimpse. As we continue our vigil, watching this mysterious visitor approach its closest encounter with our sun, we're reminded that some questions are worth asking even when we're not sure we're ready for the answers. Some mysteries are worth exploring even when they challenge our most basic assumptions about reality. The ancient wanderer from the galactic disk continues its patient journey, carrying secrets that may reshape our understanding of what it means to be conscious beings in a universe that might be far more crowded, far more watched, far more intentional than we ever dared to imagine. Next, we'll explore an even deeper mystery, how the discovery of objects like 3i Atlas might be connected to a phenomenon that challenges our understanding of time itself. Why time moves slower in deep space. The universe's hidden clock. A journey into the strange relationship between consciousness, observation, and the flow of time that governs everything from quantum mechanics to the expansion of the cosmos itself. Until then, rest well, knowing that as you sleep, ancient travelers continue their silent journeys through the dark between stars, carrying with them questions that may one day become answers, mysteries that may one day become revelations, and perhaps most importantly, reminders that in this vast and patient universe, we are neither as alone nor as unnoticed as we sometimes believe ourselves to be. Sometimes, in the deep quiet of night, you might find yourself standing at a window, looking out at the stars and suddenly feeling as though something is looking back. It's an ancient sensation, this prickle of awareness that we're not alone in our observations. Tonight, as we continue our gentle exploration of the 3i Atlas mystery, we find ourselves confronting a profound shift in perspective, the possibility that humanity has moved from being the observers to becoming the observed. This transition carries weight that extends far beyond astronomy. For the first time in our species' history, we may be facing evidence that intelligence exists on scales we never imagined, operating on timelines that dwarf our entire civilization. If 3i Atlas represents technology from an ancient galactic community, then every radio signal we've sent, every satellite we've launched, every step we've taken toward becoming a spacefaring species has been watched, catalogued, perhaps even evaluated. The implications ripple outward, like stones cast into still water. Our entire understanding of cosmic solitude, of humanity's unique position in the universe, begins to shift. We are no longer the curious children pressing our faces to the cosmic window, wondering if anyone else is out there. We are the subjects of study, the civilization being examined by minds that have been contemplating the universe since before our world began to cool. This reversal is both humbling and profound. For centuries, we have been the ones asking questions about the cosmos. We have built telescopes, sent probes, listened for signals from other worlds. We have imagined ourselves as the seekers, the explorers, the ones reaching out across the vast darkness in search of connection. But what if we have always been the ones being sought? What if our every transmission, our every technological achievement, our every step toward the stars has been monitored by observers whose patience is measured in geological epochs? The ancient wanderer that approaches our sun carries within it represents intelligence. Then that intelligence has watched its frozen core the accumulated wisdom of eons. If the rise and fall of countless civilizations has seen the patterns of growth and collapse that characterize young species across the galaxy, from such a perspective, humanity might appear as just another experiment in consciousness, another test case in the long process of galactic evolution. Yet there is something uniquely poignant about our particular moment in this cosmic drama. We stand at the threshold of becoming a truly spacefaring civilization. Our robotic ambassadors already exploring the outer planets, while our telescopes peer ever deeper into space. We are developing the tools to detect and analyze interstellar visitors, like 3i Atlas, even as we begin to suspect that such visitors might be studying us with instruments of unimaginable sophistication. There is an elegant precision to orbital mechanics that makes the universe predictable, even when it surprises us. The gravitational dance of planets and comets follows laws so reliable that we can calculate their positions centuries in advance. This mathematical certainty is what makes the trajectory of 3i Atlas so remarkable and so unsettling. When astronomers trace the object's path through our solar system, they find a route that maximizes observational opportunities while minimizing detection risk. It approaches from the direction of the galactic center, where ancient stellar populations might naturally harbor advanced civilizations. It passes close enough to multiple planets to conduct detailed reconnaissance, yet maintains sufficient distance to avoid gravitational capture or collision. The timing of its closest solar approach reveals another layer of mathematical elegance. As 3i Atlas rounds the Sun in late October, it will be positioned directly behind our star as viewed from Earth. This cosmic eclipse effectively shields the object from our most powerful telescopes during what should be its most active and revealing phase. Such timing could be coincidence, but the probability calculation suggests something more deliberate. Consider the complexity of planning such a trajectory. An interstellar mission would require not just advanced propulsion technology, but predictive models spanning millions of years. The planners would need to account for stellar motion, gravitational perturbations from passing objects, even the slow evolution of our solar system's architecture. They would need to time their arrival to coincide with humanity's emergence as a technological species, a window that represents less than 1/10,000th of our planet's history. The mathematical precision required for such planning suggests intelligence operating on scales we can barely comprehend. These would be minds capable of thinking in cosmic time, of executing plans that span geological epochs, of maintaining technological continuity across periods longer than the entire history of complex life on Earth. Yet perhaps most remarkably, the trajectory of 3i Atlas appears to account for humanity's own observational capabilities. The object reveals itself to our detection systems at precisely the moment when we have developed the tools to study it meaningfully. It arrives when our space telescopes can analyze its composition, when our Mars orbiters can observe its close planetary approach, when our understanding of interstellar objects has reached the point where we can appreciate its anomalous characteristics. This synchronization between the object's arrival and our technological readiness suggests either extraordinary luck or extraordinary planning. If intelligence is behind 3i Atlas, then that intelligence has been monitoring our development closely enough to time a multi-million-year mission to arrive at the optimal moment for first contact or first confirmed observation. The mathematics of such surveillance extend beyond mere orbital calculations. They encompass the careful study of a civilization's technological progress, the prediction of when that civilization might be ready to recognize artificial objects in space, the assessment of whether direct contact or continued observation would be the most beneficial approach. From this perspective, 3i Atlas becomes more than just a mysterious visitor. It becomes evidence of intelligence so advanced that it can treat star systems like laboratories, timing interactions with emerging civilizations with the precision of a carefully orchestrated experiment. In the deep quiet of space, silence carries meaning. Every radio telescope that scans the cosmos is listening not just for signals, but for the spaces between signals, the patterns of transmission and pause that might reveal intelligence behind the noise. With 3i Atlas, we encounter a different kind of silence, one that speaks volumes about the sophistication of whoever or whatever might be guiding its journey. The object makes no attempt to communicate with us directly. Despite its massive size and unusual properties, it sends no radio signals in our direction, displays no obvious artificial structures, makes no gestures that would be immediately recognizable as attempts at contact. This silence is so complete, so deliberate, that it becomes a form of communication in itself. Advanced civilizations would understand that first contact represents one of the most delicate moments in any species' development. The psychological and sociological impact of confirmed extraterrestrial intelligence would reshape every aspect of human culture, from our scientific worldview to our religious beliefs, from our political structures to our sense of cosmic purpose. The sudden knowledge that we are not alone, that we are in fact being observed by intelligence vastly superior to our own, could destabilize our civilization in ways that no amount of preparation could prevent. A truly sophisticated intelligence would recognize this danger and approach the problem with extraordinary care. Rather than announcing their presence with obvious signals or dramatic displays, they might choose a more subtle path, allowing us to discover them gradually, to come to our own conclusions about their nature and intentions. This approach would respect our psychological need to feel that we are making our own discoveries, while still providing the evidence necessary for those discoveries to occur. The silence of 3i Atlas fits perfectly within this framework. The object provides just enough anomalous data to capture our attention and spark serious scientific investigation while avoiding. It allows us to debate its immediate acknowledgement of extraterrestrial intelligence, the kind of obvious artificial signatures that would force the possibility of artificial origin at our own pace. This careful nature to consider multiple explanations, to approach balance, suggests intelligence that has learned through experience how to manage contact with emerging civilizations. These observers would have seen the rise and fall of countless species, would have witnessed the various ways that first contact can succeed or fail. They would have developed protocols refined over millions of years, tested across dozens of different worlds, perfected through trial and error on a galactic scale. The silence between signals becomes a teaching tool, a way of gradually expanding our cosmic perspective without overwhelming our capacity to process new realities. Each observation of 3i Atlas forces us to consider possibilities we had never seriously contemplated, to stretch our understanding of what might be possible in a universe that could be far more populated and far more carefully managed than we ever imagined. Even our own response to the object becomes part of this subtle communication. How we study 3i Atlas, how we interpret its anomalous characteristics, how we debate its possible origins, all of this provides information about our species' intellectual maturity, our capacity for rational analysis in the face of paradigm-shifting discoveries, our readiness for eventual direct contact. There is an old story about a gardener who tends a vast estate moving quietly among the plantings, pruning here, watering there, always careful not to disturb the natural growth patterns while ensuring that each species has what it needs to flourish. In the cosmic context, this metaphor takes on profound significance as we consider the possibility that our galaxy might be far more carefully tended than we have ever imagined. The garden hypothesis suggests that advanced galactic civilizations might view younger species not as competitors or threats, but as developing consciousnesses that require careful nurturing and protection. Under this model, objects like 3i Atlas would represent the equivalent of gardening tools, sophisticated monitoring systems designed to assess the health and development of emerging civilizations without interfering with their natural growth. This perspective reframes our entire understanding of cosmic evolution. Rather than viewing the galaxy as a chaotic arena where civilizations compete for resources and survival, we might be living in a carefully managed ecosystem where older intelligences take responsibility for guiding younger species through the dangerous transition from planetary to interstellar consciousness. The evidence for such management might be all around us, hidden in plain sight by our assumption that natural processes alone shape galactic evolution. The unusual stability of our solar system, the presence of a large moon that helps regulate Earth's climate, the fortuitous timing of mass extinctions that cleared ecological niches for new forms of life. All of these could be the result of subtle intervention by intelligence operating on timescales that make their activities indistinguishable from natural processes. Under the garden hypothesis, 3i Atlas becomes a gardener's tool, sent to assess whether humanity is ready for the next phase of cosmic development. Its anomalous characteristics, the impossible size, the unusual chemistry, the anti-tail phenomenon, would be the equivalent of a gardener's instruments, sophisticated beyond our current understanding, but designed for purposes we might eventually comprehend. This model suggests that first contact, when it comes, will not be the dramatic revelation we often imagine in science fiction. Instead, it will be a gradual awakening to the reality that we have always been part of a larger community, that our development has been guided by intelligence so advanced that its interventions appear to us as the natural unfolding of cosmic processes. The implications of this hypothesis extend far beyond astronomy into the deepest questions of purpose and meaning. If humanity is part of a galactic garden, then our struggles and achievements take on new significance. We're not alone in our journey toward understanding, not isolated in our efforts to become a wise and sustainable civilization. We are part of an ancient community of minds that spans the galaxy, each species contributing its unique perspective to a cosmic conversation that has been unfolding for billions of years. Yet the garden hypothesis also carries profound responsibility. If we are being tended by cosmic gardeners, then our choices matter not just for our own survival, but for our worthiness to join the community of advanced civilizations. Our treatment of our own planet, our capacity for wisdom and compassion, our ability to overcome the destructive impulses that characterize young species, all of these become tests of our readiness for galactic citizenship. When we look into the night sky, we are looking into a mirror that reflects not just light, but time itself. Every photon that reaches our eyes has traveled for years, decades, sometimes millions of years to reach us. We see the universe not as it is, but as it was, a vast temporal landscape where past and present blur together in the gentle glow of starlight. 3i Atlas adds another dimension to this mirror of deep time. If this ancient wanderer represents intelligence, then we are seeing ourselves reflected in the observations of to form. We become both the observers and the observed, the quest minds that have been watching the cosmos since before our world began on us, and the subjects of questions, the seekers and the sought. This temporal reflection reveals something profound about the nature of consciousness in the universe. Intelligence, it seems, naturally seeks out other intelligence. The same curiosity that drives us to build telescopes and scan for signals from other worlds might be universal, manifesting in every species that develops the capacity for abstract thought and technological manipulation. From this perspective, 3i Atlas becomes a mirror, showing us what we might become. Patient observers conducting careful surveillance of younger civilizations, operating on timescales that span geological epochs. Viewing the rise and fall of species as billion-year age places it in this chapters in a much larger story of cosmic evolution. The object's 7 mirror of deep time with startling clarity. When 3i Atlas first formed in some distant stellar nursery, our sun was nothing more than a slowly collapsing cloud of dust and gas. Earth did not exist. Life had not yet begun its long journey from simple chemistry to complex consciousness. The entire history of our planet, from its formation to the emergence of the first microbes, to the eventual evolution of human intelligence, has unfolded during 3i Atlas's journey through the cosmic dark. Yet here we are, at this precise moment in cosmic history, developed enough to detect and analyze this ancient visitor, mature enough to contemplate the possibility that it might represent intelligence, wise enough to consider what its presence might mean for our understanding of our place in the universe. The synchronization is remarkable. After billions of years of wandering through space, 3i Atlas arrives just as humanity reaches the technological sophistication necessary to recognize what we might be looking at. The timing suggests either extraordinary coincidence or extraordinary planning, a rendezvous scheduled across geological time, timed to occur at the moment when we would be ready to appreciate its significance. This mirror of deep time also reflects our own future possibilities. If we survive the challenges that face our young civilization, climate change, resource depletion, the risks of advanced technology, we might one day find ourselves in the position of the observers rather than the observed. We might develop the patience to think in millions of years, the wisdom to guide rather than exploit, the technology to monitor and nurture emerging civilizations across the galaxy. The ancient wanderer approaching our sun carries within its frozen depths the accumulated experience of eons. It has seen the birth and death of stars, the formation and dissolution of planetary systems, perhaps even the rise and fall of civilizations we can barely imagine. It serves as a reminder that consciousness, once it emerges in the universe, tends to persist, to grow, to reach across vast distances and timescales in search of connection and understanding. There comes a moment in every civilization's development when it must confront the possibility that its actions carry consequences beyond its own world. For humanity, that moment may of 3i Atlas be arriving with the October approach. If this ancient visitor represents surveillance by advanced intelligence, then we find ourselves in the unprecedented position of being evaluated by minds vastly superior to our own. As October draws closer and 3i Atlas continues its ancient journey toward our sun, we find ourselves standing at the edge of a revelation that could reshape everything we thought we knew about our place in this vast, patient universe. Whether this 7 billion-year-old wanderer proves to be a natural marvel or something far more intentional, its presence has already changed us. It has forced us to look up at the night sky with new eyes, to consider possibilities we had never dared imagine, to confront the profound question of whether we have ever truly been alone. The mystery of 3i Atlas reminds us that the cosmos still holds secrets beyond our current understanding, that ancient travelers continue their silent journeys through the dark between stars, carrying with them stories that predate our entire world. In studying this enigmatic visitor, we've glimpsed something of our own cosmic heritage, the realization that consciousness, once it emerges in the universe, naturally seeks out other consciousness across the vast reaches of space and time. Whether we are the watchers or the watched, the observers or the observed, we remain part of something infinitely larger than ourselves. And in that recognition lies both humility and wonder, both responsibility and hope. Sleep well, knowing that even as you rest, ancient mysteries continue to unfold above us. And tomorrow, we'll explore another profound question. What if gravity is alive? The hidden intelligence of space-time. A journey into the possibility that the very fabric of reality itself might possess a form of consciousness we're only beginning to glimpse. We're only beginning to glimpse.